Hey guys, so I just wanted to follow up on this um, Golang Concurrency pipeline blog article. There was a whole other section afterwards that I just ran out of time on the first one on, which was digesting a tree. And I wanted to just finish this off. And this is intended to be a little bit more realistic pipeline. So also we're going to be doing this in the Playground. This is a command line version here, so I think we can get this working. I've already grabbed the first couple of sections here. I've grabbed the main and I've grabbed the MD5 all routine and stuffed it into the Playground. One cool thing, I never noticed this before, if you click the imports thing, when you format it, it'll bring in all the imports necessary. So let's have a look at this program so far and keep going with the article and just see what's happening here. So the idea is that we give it a wildcard and it'll grab all the files in the working directory and give you an MD5 sum for each of the files. And it has to do that by opening each file and then adding up all the values inside of it. It's just like the command line version, or the standard version. So that's all pretty cut and dry. If you can see where I ran it here, and we can see the files from the Go Playground sandbox, which is kind of interesting. So this seems to work okay. And if we look through the code here, the first thing we're going to do is we take the args. One thing you'll notice is I changed the args here on the main, just be dot for the current directory because I can't seem to pass that in. Okay, so it grabs all those things and it returns a structure, and then we run through this and get a list of paths, and then we sort them, and then we show the sum, the MD5 of all the paths. So that's not too bad. Let's look at what the MD5 does. It returns a map string to an array of bytes, the length of a MD5, and an error potentially. So it makes that map, then it does a file path walk from our starting point, which is the root, and then it does this function for every entry that it finds. If it's not a regular file, which means it's probably a directory or something, then it bails out. Otherwise, it opens the file, does an MD5 sum on the data, and then returns that dictionary with any potential errors. So this would be expensive to do, obviously, if we had a lot of files in there, because it has to open each file and read it and stuff, and so it sort of lends itself to parallelism, which is where we're sort of headed with this. So in parallel.go, we split the MD5 into a two-stage pipeline. The first stage, sum the files, walks the tree, digests each file into a new Go routine, and then sends the results on a channel with a value type result. So we're going to need this little structure here. We'll add that. Okay, so we've got the path, we've got the sum, which is basically like the dictionary that we had before, and the error. So some files returns two channels, one for the results, the other for the error returned by the walk. Okay, that's an interesting approach. The walk function starts a new Go routine to process each regular file, then checks done. If done is closed, the walk stops. So very similar to what we saw in the last one. So let's just grab this and then we'll see what's involved. We'll do a little walkthrough of that, and I think MD5 has changed as well because now it's got to use the channels. So MD5 all still takes a root, so here's our done channel, and it passes in the, so it's pretty, no, it's, yeah, it's different because it's got the map, and then it's got the error channel, and it's looking to see if we got any errors out of that. So we're just going to grab this whole thing here and replace our other MD5 all routine with this new one. Okay, and let's format that, see what we got. and run it. Okay, so that worked as well. Could add some time into this to see if it's much faster. But let's see what's happening in this new some files thing here now. So we're going to take in our done channel and where we're going to start our walk from. Well, actually, is it our walk? Yes, it is from our walk. So then we're going to make a channel and then our error channel. So one has our results in it, and then one is our channel of errors, only one deep. That's interesting. So we're going to get some blocking happening here. And this is our, so we'll fire this off straight away, this go function, because this is just going to get called, and we're going to return that channel and the error channel right away. So this is going to start going, and then we're going to return from this right off the bat. So first thing we do is we set up a wait group. We start our walk. As we find a file, we add to our working group, or to our wait group, I'm sorry. And then we start this function here, which is the thing that does the open and adds the result onto the channel of the MD5. So this is very similar to what we saw before inside this little function here. And then if the channel was closed, right, so this will block otherwise, but then if something comes in on the done channel, or if that channel is closed, then it'll bail out. Right. Like we saw in the last example. So this is going to happen straight away. And okay, so that's not so bad. We're going to fire one of those off for each file that we find, and then we're going to check to see if the done channel is closed outside of this, or maybe as a result of this. So this seems to be the standard way to find out if a channel is closed or not, but I thought there was a closed method you could do. We'll have to revisit that. So if it's closed, then the walk was canceled, and otherwise no errors, so we would return a nil right from this. So our walk is finished, so walk is returned, so all calls to wait group add are done, right? We've added all for each file. And now we want to wait on this and then close the channel to say that we've got all our items. And then on our error channel, we're going to write any error that occurred. Now this is a single error. So this is an error off the walk. So that's why we've only got one, I suspect. Yeah, so that could be a nil that goes on there. So in this case here, the only difference in this was make the two channels, pass in that, get the results, and then at the end, we try and read from the error channel. Well, we do read from the error channel because it's going to have something in it. And if it's not nil, then we know we got an error. And otherwise we return our map again. So this all looks the same. The only difference is that now we have a structure that we're going to do here, and we check the structure, see if an error occurred, and otherwise we build up the map like we did before. So all the rest of it looks the same. This result structure is just used internally temporarily. Okay, so it's not so crazy. That error one though, I do want to check this again. So something's going to go in here no matter what. And the blocking, we're only going to have one entry go in it for each one. Let's just look at that again. So MD5 all, sum them all up. So we haven't done any parallelism here yet until we get up into some files, at which point this is where the parallelism occurs. So this is an overall, the reason it's only one deep is we're not going to get any more than one in it. There is no blocking that's going to occur really. It'll always feed something into it. So I guess the question is, why return a channel for that? And why not return just an error? Oh, okay. Because, so the one thing I was wondering is, why return an error channel when you can just return an error? But the thing is that this is going to return straight away, and we're going to return the channel. So what we'll do is we'll get the channel here. This is still chugging away. We do the work. This is going to block, waiting for everything to finish. So this is the signal, rather than do a wait group or anything. This is a signal from some files to say that I'm done. Okay. It's a little bit, I just find it a little confusing that it's an error channel, but it's really the indicator to say that this is all finished. Right. So, well, here we go. MD5 all closes the done channel when it returns. It may do so before receiving all the values. Right, so if it's canceled out, so in this case we cancel out and the done channel was closed, let's say prematurely, and we return this error here. Right, okay, so this is the function that returns the error. Yeah, okay, so now this makes more sense. So the error is effectively the error that this returns. So in this case, we're going to fabricate an error. If it was canceled here, it just bails out, and then we push one or the other on, and that's why that signal works. Okay, it works for me, and that works pretty cool. All right, good. Bounded parallelism. The MD5 implementation of parallel starts a new Go routine for each. Okay, so now it's going to explain what actually just happened, which we sort of tried to figure out. In a directory with many large files, it may allocate more memory than is available on the machine. We can limit these allocations by bounding the number. Oh no, this is a different extension. We can limit the number of allocations by bounding the number of files read in parallel. In bounded Go, we do this by creating a fixed number of Go routines for reading files. Our pipeline now has 3 stages: walk the tree, read and digest the files, collect the digests. Okay, the first stage, walk files, emits the paths of regular files in the tree. Okay, so before our walk files was just an inline function. So now this is getting a little bit more funky here. So we've got that. We've got a new thing at the middle stage. It's the digester, which is going to grab all this stuff and actually sum them up. So this is what we've seen before. It's just broken out into another function. Except that the paths now come from a channel as opposed to walking it directly. Unlike previous examples, digester does not close its output channel as multiple Go routines are sending on a shared channel. Instead, code in MD5 all arranges for the channel to be closed when all the digesters are done. Okay, so so this is going to be our new MD5 all function. We could instead have a digester create and return its own output channel, but then we would need additional Go routines to fan in the results. All right, we'll look at that in a second. The final stage receives all the results from C, checks the error from error C. This check cannot happen any earlier because before this point, walk files may block sending values downstream. Okay, and so this looks very similar to the previous one. Okay, so I'm just going to, because this is a lot of snippets in here, I'm just going to jump over and look at what they did here. We can just drop this one right in, I think. And let's just format it and run it. Oh, yeah, right. Forgot. Gotta change that. Okay. So let's just see how this changed. So in the previous example, what we had seen was that this was done in a linear fashion. That the walking was done in a linear fashion. And then there was a go routine done. All right, let's go into it and see what happens here. Okay, so we're going to do an MD5 on all, and then this formatting for the output is the same. So we get up to MD5 all. Same sort of deal. We've got our done channel, and then we're going to do walk files and start a fixed number of go routines to read and digest the files. Okay, so this is going to be our result channel. Not sure what HLC is. We've got a wait group. We've got a cap on our digesters, 20. I wonder if I can, just out of curiosity, see if I can get a few more files further up. Or can I do /bin maybe? No big deal. All right, 10 member files. So let's see what we got going on here. So we make a channel for our results. Got a wait group. We're going to do 20 digestions at a time, or maximum. And then for each of them, then we're going to start a go function, which is going to call our digester. We've got the same done channel. We've got our paths that are, well, let's look at that in a second. These are going to be a channel now, I think. And then we've got our results, where the results are going to go. And then we just wait for all the digesters to finish. Oh, well, no. We say that that wait group is done. That part of the wait group is done. In this case, all right, so this is what's going to be curious. In this case, we've only got 5 files, but we've got 20 digesters, so it's going to be curious to see when this fails, how that catches that. So this is where we do the wait, and then we close it. So that's just going to happen in another thread. So at this point, we've just run right through this. This is waiting in a different place for these to all finish. Oh, and then we close that channel. We close the results channel. Okay, so we wait for everything to happen, then we close the results channel. So this is going to happen down here straight away. So this is the same sort of structure that we've seen before. This is our results channel. And so we're going to start reading from this right away. This will block initially because there's nothing in it. And we have a result. If there's not an error, then show that there was an error. Otherwise, populate our results file. And same sort of deal here. Wait for wait to see if there's anything that failed here. All right. So up to now, we're very similar to what we had before, except for this digester code. So a digester, well, let's look how walk finished first. So in this case now, walk takes our done channel and the start of the search, and it returns a channel with the results and an error channel. So same sort of deal. Error channel has 1 in it, so we know we're going to get 1 entry. It's going to be nil, or it's going to have something in it. These HLs and HLCs, I don't know what they stand for. Does it say anything in here? Oh, maybe it's a highlight. All right, it's markup. Yeah. So it's just markup. So in here, I bet you it's mark. Yeah. Okay. Very clever Go Playland. Playground. So let's look at walk files. So grab this. We're going to close out the paths once we finish it. The error is going to go straight into the error channel. And we're going to do this. This is still being done in a linear fashion as well. So our walk, so our walk only occurs once as well. Okay. So this is just done in a serial fashion, same as before. But all we're doing now is we're just stuffing all the files into it. And if someone bailed out, then put an error in, and then at the end of it, just return our paths channel. All right. So first stage, fill up the list of paths to deal with. So that's what we've got here. We've got all of our paths. These are 2 channels. If anything failed in there, we'd want to be able to catch that. So now we've got these digesters. It's going to take in. It doesn't look at the errors until way down here. Okay, but errors is not used anywhere else until the end, and done doesn't get set. Nothing's closed on done. All right. I'm not sure why. Seems almost unnecessary. So we've got some error that may have happened here. All right. So now we've got all these things that we want to, so we're going to fire off a bunch of these, and these are going to all consume from the paths in parallel, I would assume. Open them, do all the work, and then say that they're finished. So let's see what they do. They open up the paths, right? They read it, and then and if it closes, and then the channel gets the result. Okay, so we can do 20 of these in one fell swoop. I guess the question is, why is this better than the last one? Oh, well, because it's bounded, right? So in this case, we've got a cap on the number of files that we can open concurrently, and we cap it at 20. And in the previous example, what we saw was we go through the walk, and then we just do this every time. Right, so if we had 1,000 files, we'd have 1,000 Go routines here. Okay. All right. Interesting. There's some decisions here I'm just feel a little awkward to me. This idea of the error channel up front. Like for example, this error channel being set up here and only being used down here. So it almost seems like we've lost. So that's where the results go, and they have an error in it potentially. And So that's the error that could come back from any of those. But this error up here is the error from walking. Right, and then check to see if the walk failed. It just seems backwards. It just seems like, you know, we'd want to, if the walk failed, we'd want to bail out first. So wasn't there a comment about that? We had to do one thing before the other? Yeah, the final stage receives all the results from C and then checks the error value from error C. This check cannot happen any earlier, since before this point, walk files may block sending values downstream. This check cannot happen any earlier. Because my gut says that should be up here, but why can that not occur any earlier? So we've got the channel and it's still filling it up. This thing is waiting to, like, with eager anticipation to consume from the paths. And because we're capped at 20. So let's say there's 1,000 files up here, and this thing is only going to do 20 at a time. It gets to 20, this is blocked, and then later this error occurs. So later, let's say on file 21, this results in an error. Then if we did this here, this is waiting for all the results to come through. And if we did this earlier, this could be blocked waiting on the digesters. Aha. Okay. So, I mean, this is probably a place where our done channel could be used a little bit more, so that if something happened up here, we could probably, well, couldn't we kill, if this, okay, well, we could probably do that. I mean, couldn't we close our, if we up here detect, if in here we detect that there's an error, something goes into this error channel, couldn't we close the done channel? Then it's not going to digest the rest. It depends on where we want to short circuit it. Yeah, it gets a little complicated. So that's an interesting subtlety that this has to happen here. So once, I guess the lesson here is that when you're capping your parallelism, that you have to make sure that this is actually drained out first, which makes sense. Okay. Hopefully, sorry, I had to understand this myself. So I know that seems a little bit roundabout, but hopefully that made sense to you as well. That was a good little blog article. Still, some of the code still strikes me as a little odd, but I do like the idea here. So in the next one, we'll grab some other blog article, and we'll see what this does. Let's see what the conclusion here is. This article represents techniques for constructing streaming pipelines in Go. Dealing with failures in such pipelines is tricky, since each stage in the pipeline may block attempting to send values downstream, and the downstream changes may no longer care about the incoming data. Correct. That's what we just determined. We show how closing a channel can broadcast a done signal all Go routine started by a pipeline and define guidelines for constructing pipelines correctly. Okay, so we've got a couple of videos here we can look at. Maybe we'll go after one of these, but there's a bunch of other. The context with the concurrency patterns is probably the one I'm most interested in. Maybe we'll look at one of these next. Cool. All right. Thanks. Hope that was useful. Bye.